Cool, today we're going to take a look at Functor in Haskell. In particular, we're going to take a look at fmap, aka $ in angle brackets. Let's take a look at the type signature. Okay, here we have the type signature for fmap. Let's take a look at the second argument here. So there is a value of type A, which is wrapped inside of a context f, which, as we can see here, is a functor. Now, let's take the example of f as a list and a as an int. Now, an int by itself, it's a value, which could be 1, 123, minus 10. But if we wrap that int inside of a list, now we made the int more powerful somehow. So we could have 0 ints, we could have 1 int, or we could have many ints. Also, we could consider f as a maybe. So in the case of maybe int, we could either have 0 ints or just 1 int. Explain the context part, we can see that fmap is kinda easy. So we have 2 arguments. The first argument is a function from a to b. And the second argument is a value a of type A wrapped in a context f. And it's easy to imagine that the way this works is that we somehow take the value out of the context, we apply this function here, and then we return the result of applying that function wrapped in the same context f. In the previous video, we took a look at the $ operator, and here we're taking a look at fmap. So I think it could be useful to take a look at those two side by side. As you can see, the only difference here is that we are introducing a context f, wrapping the second argument and the output. Now, in practice, the difference is that in the case of $, this value a is always applied to this function to produce the output. In the case of fmap, we can say the same, but there's this context f here, which works as this discriminator. Meaning that the way this function here is applied depends on the specific semantics of the context f. Each functor has different semantics. So here we're showing 2 examples. One is list and the other one is maybe. So in case of list, we can see that when we apply +1 to a list of 3 elements in this case, we +1 each element. So here we would get as an output a list 2, 3, 4. In the case of an empty list, we just don't do anything. We return an empty list. And these are the semantics for list. In case of maybe, we can see that in case of just, we apply the function to the value that the just is wrapping. So here we would get as a return value just 2. And in the case of nothing, we don't do anything. So the return value would be nothing. And that was fmap. We made it. If you have any feedback, please let me know. See you next time.